I'm Anil Kumar, and here is the solution for your thinking question on sequences and series. The question was Sn equals to a times r to the power of n minus 1 divided by r minus 1, where r is not equal to 1 and n is belonging to set of natural numbers. Now this one is a formula for the sum of a finite geometric series, correct? Explain how you would determine the sum of infinite geometric series like given here. 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 and so on. Well, the series given to us is 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus so on, right? Now this formula clearly has n, right? That means n number of terms are finite. Here, since these dots are given at the end, this just continues, and we need to find sum of this series. That means it could go to infinity. How do we do that? That is the question. Now, whenever you have infinite series, let me give you some background here. We are now talking about infinite series. In that case, we have two cases. One type of series could be divergent, and the other could be convergent. Now, divergent means that a series like which increases, right? So divergent means increasing. And convergent means decreasing. Now that makes huge difference. Decreasing means r value, that number by which we are multiplying every successive term, the absolute value of r, if it is greater than 1, then it is increasing. But if absolute value of r is less than 1, then it is decreasing. Now if we have an increasing series, then the sum of infinite series will be infinite, since it just increases, correct? Unbound. But if we have a convergent series, then r, as you can see, is less than 1. In that case, what really happens is, in that case, r to the power of n, as n approaches a large number, say infinity, in that case, r to the power of n approaches what? If I have r as smaller number, as in this case, let us say half, then less than 1, let us take this example, r is where less than 1, then it approaches what? It approaches 0, right? It becomes smaller and smaller, smaller and smaller, and it approaches 0 if r is less than 1, right? So 1 divided by a large number, let's say a large number, a very large number, will be a very small number. So that is the concept. So we'll use this concept to solve the given question, right? Now what we are saying here is that a is equals to half, the first term, and r is equals to what? Ratio of consecutive terms, that is 1 over 4 divided by 1 over 2, which is 1 over 4 times 2 over 1, or equals to half, right? Now if we find the ratio of the next two terms, 1 over 8 and 1 over 4, ratio is still the same. If we do 1 over 8 divided by 1 over 4, we do get half, right? So the ratio is constant. So r is half for us, correct? So we can write r is half. Now if I have sum of this series where n is very large, infinite, right? In that case, applying the same formula, r to the power of n minus 1 over r minus 1. If r is half, let us say, right? Let me write half here. We can write a is half for us. We'll write a as half. And then half to the power of n minus 1 divided by r is half. Half minus 1. Now if n is very large, then half to the power of n is 0. Do you see that? Approaching 0. So we could write this as half times minus 1 divided by half minus 1 is how much? Half minus 1 is minus half, right? So we get 1 as our answer, right? So sum of this series for infinite terms is 1. So that is how we do it, right? In fact, the formula could be written as for sum of infinite series, sum of infinite terms, I should write, right? S will be equals to A over R minus 1, and this is 0 minus 1, so I'll write minus A over R minus 1, or I could write this as A over 1 minus R. So the sum formula becomes A over 1 minus R, right? So if I use this formula directly, I get the same answer. Reason as explained here, if R is less than 1, for example a fraction like we had here 1 over 2, then 1 over 2 to the power of a large number will be 0, right? I hope you remember the graph. Let me just share with you the graph of an exponential function, right? So graph of an exponential function is kind of, if it is approaching 0, right, as infinity. So that is how it is if we take b to the power of x, where b is absolute value of b, I should say, is less than 1. You get the point, right? So if absolute value of b is less than 1, in that case it is always decreasing. Do you see that? Approaching 0. So that is the whole concept. I hope that helps. Thank you. Well, in this case, when we are talking about absolute function, b has to be, I should write b is greater than 0 but less than 1, to be very clear about it, right? Because in exponential functions the base should be positive, right? So that is how it should be. So whenever the base is less than 1, in that case the formula changes, and we could write the formula as a divided by 1 minus r. I hope that helps. Thank you.